Okay, so now we're going to look at what happens if we want to have two different projectiles meeting in some way. So for example, let's say we have someone that's going to fire a missile with a velocity v0. Okay, and we know that they're going to fire that missile at our city. And so we know that the distance between the two is just the range, which is going to be r. But because we know that the other people might be firing a missile, we decide to go halfway across. And so at r/2, and we put up some missiles of our own, and they go at the same velocity, the same initial speed that the other person's missiles go. So that when we launch our missile, we want them to come up and we want them to intercept the other missile right above us. We don't have to necessarily have to go right above us, but this will just make the math a little bit easier. Okay, so the only thing we really need to know now, if we have radar, so we can sufficiently detect what their angle is. So when they fired their missile and what angle they fired it at, what we want to know then is when do we fire our missile? Okay, so now this involves two sets of equations, right? We're going to have one set of equations that are governed by the first missile, and then we're going to have another that are governed by our missile that we want to intercept it. Okay, so let's look at what we know about this. So the first thing to do when trying to solve like a simultaneous problem like this is to realize what conditions we want to be the same. So we want the height of the first missile to equal the height of the second missile, right? Because this is they're going to have to collide at the same height. We also want the distance x traveled by the first missile to be the location r/2, because we're firing it straight up. So we want that to be the location of our missile silo. And then we also know that the time that it's going to take for the first missile to get there is going to be equal to the time that the second missile is in the air, plus the time that we wait. And what we're really interested in finding now is the time that we wait before we fire the second missile. Okay, so there's a couple different ways we can find the height, right? The first way is we can use conservation of energy and say 1/2 m v0 squared is equal to mgh plus 1/2 m v0 x squared. And so we divide by m, we rearrange, bring this term over, and of course this is v0 cosine theta. And so we say that, and we divide by g, so we say that h is going to be v0 squared 1 minus cos squared theta all over 2g. Well, 1 minus cosine squared theta is just sine squared theta. So in other words, h is v0 squared sine squared theta over 2g. Okay, we could have also gotten this in the exact same way using our equation for y, using our y equation of motion. Okay, the next thing we can do is we can find out what the time, we can find t, the time that that the first missile is going to be in the air, because we know that 0 is equal to vy, which is vy sine theta minus gt. And as we've seen several times already, this means that t is going to be v0 sine theta over g. Okay, now we can find the time that our second missile is going to be in the air, because we know that we don't know that Vy prime is going to be 0 when they collide. In fact, we know that that's not true. Because if this one's being fired at some angle theta, then we know that if we fire it straight up, this is going to end up going higher, and then it would come back down if we missed it, and it would land right on top of us. So we definitely don't want that to happen. So in other words, this isn't a very realistic scenario. You probably wouldn't want to fire a missile that if you missed, it would come right back down and hit you. But again, for solving the problem, it just makes the math a little bit simpler if we do this because of the way that we found h. So we know that we can't use the Vy equation to find t, and that's unfortunate. We also can't use the Vx equation to find t. So this is one of those instances where we actually have to use the quadratic form of this. Okay, and so to do that, then we say that, well, we know that h is going to be v0t minus v0t prime minus 1/2 g t prime squared. Okay, and so rearranging, we have that t prime squared 1/2 t prime squared g minus v0 t prime plus h is equal to 0. So t prime is equal to v0 plus or minus the square root of v0 squared minus 4ac, so 2hg or 2gh all over 2a, which is just g. So this is t prime. And then of course we can always sub in h from over here. And so we notice that if we do that, this term on the inside, we have v0 squared minus the 2g's cancel out. And so we have v0 squared sine squared theta. And so this just becomes v0 squared cos squared theta. So in other words, t prime is equal to v0 plus or minus v0 cosine theta all over g. Right? So now, do we want the plus or the minus? Well, it really doesn't matter. This is telling us that there's two different times where this missile is going to be at this height. So if we look at the minus, that's going to be an earlier time, right? And that's going to be the time when we hit it on the way up. The other time would be when we hit it on the way down. So for argument's sake, we probably want to try and hit it on the way up, right? So we want to say then that our t prime is going to be v0 times 1 minus cosine theta divided by g. And so that means that the time that we wait is going to be t minus t prime. So this is going to be v0. Let's see. So t is v0 sine theta over g minus t prime, which is v0 1 minus cosine theta all over g. So the time that we wait is v0 over g sine theta plus cosine theta minus 1. And so we check our units and we see that this makes sense. We have meters per second divided by meters per second squared, which has units of seconds. We know that sine theta and cosine theta, neither one of them is going to be, are always going to be less than or equal to, 1. If we fire straight up, then that theta is 90 degrees, then this is 1. If theta is over, this is 1. And so this would give us the answer as to how long we would need to wait. So now you can see, how to go through different steps to find, we're solving basically two equations side by side. So the first step was we had to find out what's the same in both scenarios. And then from there, we just find each of these parameters that we know is the same, by using that equation.